Hello, my name's Tim Martel, and today I'm going to be talking about the ACB PHribbon and Embodied CO2. For many years, architects and designers have been starting to consider CO2 when designing Passive House, and the embodied CO2 part of that is something that's gathering interest at the moment. But so far, this has been quite difficult and time-consuming to calculate. Or the other alternative is that sometimes it only considers the manufacture of materials. So it would be useful to have some software to produce the calculation, and PHribbon is one example of that. It's been available in the UK for a couple of years, and it works from a toolbar in Excel. Here's my attempt to produce a draft version in Spanish. It's not finalized yet, but that gives you an idea. So as well as talking about the embodied CO2 part of it, there's another consideration. If we're going to be designing low energy buildings, and there's a large government following for that, then we might well become very busy as passive house designers, and that would mean that it would be useful if we could have some tools to make our job a bit faster and without any mistakes. So I'm just going to mention in this presentation as well one of the other features of PHribbon. There's quite a lot of features in it, but I'm going to mention one of the other features which helps enter windows. So I'm going to go to a live demonstration now. And here is a PHPP, and it's a normal PHPP, and we have PHribbon installed in the corner here. It's just like any other tab, and this is the Spanish. I'm showing you the Spanish version. And if we wanted to enter a window, we could press this window button here, and it would ask us for a selection. We just put in a type of window like this. We can then put in some dimensions. 1200 C, let's say that's 800, and D 350. And then it does take frame information from the PHPP. I'm just going to use some very simple information to start off with. These 6 numbers here are the 6 windows, the 6 panes that we can see there. You can just about see there's a number there. So that's those. We give it a name, call it W1. And then here's where it's going to appear over here. So we press write, and it will write that. And it writes the window sizes there, the dimensions of each pane, the frame information, the 1s and 0s, but much better than that is that it calculates the D-reveal. D-reveal is quite complicated to calculate yourself, and it puts it in as a formula which allows you to see exactly where the information came from. It also calculates the D over, which is not so straightforward. It takes information from the frame size and also the size of the window above it. So that's a little bit of an aside, but that's one of the things that could be useful in PHribbon to speed up windows. And you could imagine if you're spending all day entering windows, something like this could really help speed that process up. So I'm now going to go back to the presentation. And now we're going to start to talk about embodied CO2. Embodied CO2 is composed of several stages. We have the stage where the products are manufactured here. We then have construction, use, and the end of life. And there's also some things beyond the life of the system there. And we are very lucky in the UK that we have a document that describes a lot of the assumptions to be used for this in quite some detail. It's written by the Royal Institute of Chartered Surveyors, and this is the front page, whole life carbon assessment for the built environment. And in there, it goes through a lot of the assumptions. So, go backwards, forwards. So if we were to graph just stage A1 to A3, we'd get something that looked a bit like this. We have the bars here, which are emissions, and then below the zero here, below the axis here, we've got carbon stored. And this is for 3 different types of construction that is commonly used for passive house in the UK. And over here, there is the breakdown of the materials that are used for these same bars. So same thing, just showed in terms of materials. But that's not all, because we've got these other stages. So if we added A4 to A5, we'd get something that looked like that. That's a little bit more. And if we added B and C, then we'd get something that looks like that. So you can see that if you're only including A1 to A3, you're missing out quite a lot of the calculation. And for timber and cellulose, that is, there's quite a large part of it in stage C, which is at the end of life. So there's a couple of examples I want to go through. This one, new building in Bristol, and there's a comparison here of what you'd get if you were just doing a cradle to practical completion versus a cradle to grave. If you're doing cradle to grave, as in PHribbon, then you include the timber storage. This is below zero. Timber storage, that's the CO2 taken out of the atmosphere for the timber. Also for the timber-based materials, so that's cellulose and wood fibre. And there's also the in-use phase, B, and the end-of-life stage, C. In this example here, this is in Portsmouth, I think, in the south of the UK. In this example, we can see that there's timber storage, so carbon stored here, and again, carbon stored here, and that is offset by this large stage C here, where the reason this stage C is quite large is because one of the assumptions is that the timber is, or 75% of the timber is incinerated at the end of life. So it's important to consider that, and if we can find another route for that, that would be even better. So if we could recycle that or reuse that, that would be a much better use. But if it doesn't get planned by the architect, then it's unlikely to happen. Because the architect can design it to be possible to be deconstructed or reused by the choice of materials. So I'm going to try and compare a few more examples now, and in order to make the graphs, the top of the graphs line up, I'm going to shrink the graphs a little bit. What you have to do is add together all these positive parts and all the negative parts together. So you start with 600 and you subtract 300 and you get 300 overall, and that's the overall CO2 of the building. And for this one too, you have to subtract this negative part. So I'm going to do that by shrinking the graphs. There we are. So now the height of that, this one is lower than this one. So this is actually better. And if we compare a few others like that now, this one, a detached house in Hampshire, this is the way the building was built. This is a comparison of how it would be built if it was a normal cavity wall construction. So it's much better. Well, it's a little bit better. And then a semi-detached timber and EPS, that's expanded polystyrene bead. That's slightly better again. And a terraced house with which has been brick clad. This one, the brick is making it slightly higher. And then this one here, we just saw, that's got PV in it and it's a detached house, so it makes it a little bit higher. So I'm now going to go just briefly to show you what it's like to use. It's all nice to see the results, but what is it like to use? So I'll just go to another example. See, stop that. Okay. We have a U-value tab, and I'm just showing you this because the U-value tab in PHribbon is what the embodied CO2 calculation starts with. So when we start the embodied CO2 with this tool here, it asks us if we want to start a new calculation or add to an existing one. So we're going to start a new one and then press add. And it's written a new tab called Embod, and we just start listing materials. These are the materials that it was showing us before for this U value, and it's matched this one up with these in its library, and that's not a bad choice there, so we can write that one and it'll start writing that selection. This mineral wool one, we can specify that one, and then this brick outer layer, well, that'll be the same as that one. And EWI rock wool, if it's not listed in there, rock wool is a trade name, so if we put in mineral wool, then it'll find that and we can choose that one. And then we've got a render. So we can go through our other U values. If we went through the other U values, we can go through and do those in the same way. And there's special tools for adding studs and timber and I-beams and all that. So then what happens after you've entered all those, you go back to the main menu and you can add windows. Here you can choose, well, let's choose some triple glazed windows. There's a good selection there, or you can add your own. If you've got an EPD for it, you can add your own. So we can write that window. This applies to all windows, but you can subdivide and you can say half of them are using this and half of them are using that. Then we can add some PV. And there are materials which are not covered in the PHribbon, and that's because the PHribbon is concerned with thermal elements, and thermal elements, some of those, well, that's around the exterior of the building, and you'd have things like internal walls which are not mentioned in the PHP, which you have to add and then measure separately. So you can add internal walls, and then you add the material separately. And if you add one of these, say, you can then enter the size and thickness separately. And the same to do with wall coverings, roof coverings, extra foundations, roofs, and all that. And then in the main menu, there's also further options if you wanted to add steel, MVHR duct, that sort of thing, ceramics. There's all that. So once you've finished with all that, you then press summarize, and it finishes off the calculation and produces a graph. And we haven't really finished it very fully, but this is the sort of thing you'd get. And for Spain, the only thing that has to be customized is these figures here, the percentage recycling of each of these materials, steel, aluminium, copper, and the travel distances. And you can actually put that in the template. There's a special template that you can put that in so that you don't have to keep on doing it. So that is a quick overview of PHribbon and the embodied part of that. Thank you very much. Hope that's been useful.